Hello. Yeah, so good day, everybody. My name is Achal Kagwad, and I am a member of the DSC 26 batch from upgrad PGD. So, yeah, so today I'm going to share a PPT for market mix modeling. So, this is a part of a capstone project which I have chosen from BA track. And I have chosen e-commerce. So, within e-commerce, we have something called as market mix modeling. And this is what we are just going to run through today. So let's get started. So just before this, maybe I'll just share my video to have a look. Yeah, so that's me. My name is Achal. So yeah, so let's get started. So I'll just stop the video again and I will start sharing my screen to run down the PPT that we have prepared and all the whatever coding that we did together as part of this whole 1 year journey. So yeah, let's get started. So I'm just sharing my screen. So I'm just using Zoom for this purpose. So yeah, okay, where were we? So cool. So yeah, so this is the typical issue framework that we need to run through. It basically says what are the loopholes and the issues with the current situation with ElecKart. So the whole issue is that we are going to build a market mix modeling for ElecKart. ElecKart is a e-commerce company based out of Canada in Ontario. So based on the inputs and feedback that we received, so we just created this small issue framework. So let's not go into depth because we just have some 8 to 10 minutes to run through the whole PPT. We'll just quickly go through this. So there are two issues. I'm basically inability to beat a huge competition in the market. So you see, if you just run down through this, why did this happen? So you have problem with acquiring new customers. Why did this happen? Because there was no mobile application present, and the existing website was confusing. So customers couldn't find the products that we're looking for. So here, if you see on the root nodes of this issue tree framework, you have the root cause analysis. So this is basically we do for root cause analysis. So this is one branch of the tree which is showing us that there is insufficient budget to hire a technical team to develop an app. There is improper product assortment, and then there is difficult for customers to easily locate what they're looking for. So on the other branch, you see there is ineffective market penetration. So if you see why this happens, so if you apply the 5i framework to this issue framework, you come to the root cause analysis. So here there are unplanned budgets, non-optimal allocation of marketing budget across different marketing levels. So here is what we are going to basically use a skill of data science and machine learning to come up with the market mix model. So here you see there is lack of market mix model, and then there is lack of price optimization. So these two are kind of go hand in hand, and we will just see. So this I just thought of just showing this in this PPT. Okay, so yeah, I'll just run through the code. So yeah, this is the code that we run. So I did around, I would say like around 680 lines of code, I suppose. Yeah, so all this stuff starting from importing to EDA and everything. So finally, I'll just not run through, I'll just run through this whole stuff here. And at the end of your Jupyter notebook, so we have the best fit lines. So we'll come to this. So all this is put in the PPT and we will just go through it step by step. So let's see how many lines. Yeah, 635 lines of code. Good learning experience. Cool. So let's go to the PPT. Where is PPT? It's here. Okay, I'll just yeah. So e-commerce capstone project, final submission report. So what's our business objective? So yeah, it's here to which KPIs drive the top line performance, and then the impact of these on our revenue, and then finally how do you optimize your marketing spend. So this is the core business objective. Of course, as a machine learning engineer, we will be looking into metrics of R square and mean square error, but on the business front, what we need to know is which levers are impacting our revenue and sales. So that would be the key step here. So yeah, we use scripts DM framework. It's a standard process for any machine learning project as such. So here we understand the business data, then we prepare the data, then we do some feature engineering, EDA and visualizations, then models, and then we evaluate the model, and finally we deploy the model. So that's the basic standard steps. Let's run quickly. We'll spend some more time in the model evaluation and the KPIs that is more for interest. So we'll just run through this quickly. So yeah, understanding data, there were like 5 files, and each file has different KPIs, and we need to get them into our model. So we have consumer file, investment file, calendars, NPS score, which is basically the voice of the customer, and then the weather file. So whether all these files, all this data go into a model. Yeah, so we have 4 P's of marketing, the standard marketing concepts. So product, so which are the metrics in this data which basically fall under these 4 P's. It's given here. So product, price, place, and promotion. I will not go into this. It's self-explanatory. We can again look into this. So basically, it's like we are drawing a map of which KPIs that we need to be looked into. So that's how it is. So yeah. So coming to the data preparation and cleanup. So again, just to quickly run through, this is a standard process before we run into the building process or building model process. So we need to clean the data and according to our needs. So the basic steps that we followed: handling incorrect values, then duplication of data, then treating null values and white spaces, then dropping insignificant columns. So single unique value columns are not significant and do not add any value. So that's why we drop them. And then some ID columns like the customer ID or something like that. Cool. So yeah, data prep and cleanup continued. So outlier treatment. This needs to be evaluated on a case-to-case basis. So which variables are actually are outliers and not. So some variables, there were some outliers, and we need to drop them. But in some cases, the outliers actually make sense. So we need to keep them in the model. So it's on case-to-case basis. So that's what we did. And we have mentioned some variables here, which we capped to the 99th percentile, so that we dropped the outliers, but at the same time we had some data. So the year, so this is important. So the whole data is a 1-year data, which is from July 2015 to June 2016 for ElecKart, which is a Canada-based company. So yeah, standard steps of binary encoding and then forming a dummy variables. Here you see additional data steps are merging. So basically, as you see here, right? So they were like all these files. So each file is basically like a data frame, and then we need to merge all these files to form a master data frame. So that's what we did here in the next step. So here, if you see, so merging and then extracting 3 separate data frames. So this is what we're supposed to do. We needed 3 product subcategories: camera, accessory, home audio, and gaming accessory. So we use the typical Python and concepts of group by and stuff like that. So to come up with these 3 data frames for the 3 product subcategories. And then we rolled the data to weekly level, which is basically if you have 1 year, we're like around 53 weeks. So that's what we did. And then finally we did train, test, split. Let's see whether I can track this somewhere here. Yeah. So train, test, split, and then dividing the master frame to train and test sets. That's what we want to do. Then finally scaling. So yeah, basically you perform the train, test, split before scaling. And then you scale the values. So that's what we did. Yeah, so why we train, test it before scaling and all that stuff is basically questions that is important, which I have put in my notebook, the answers to such questions, like why we basically first split and then we do the scaling, and why we do the scaling and which scaler we use. So I'll just not get into more details of it. It's all mentioned in the Jupyter notebook. Okay, so okay, my screen is hung, I don't know why. Okay, cannot go to the next step. Okay, where were we? I think I have to use I don't know, for some reason My laptop keys are not working, but my mouse is working, so fine. So next we did feature engineering. We created some features that were necessary for a model from the existing features. They are like some engineered features which are necessary. So payday week, holiday week, product type. Product type is kind of important. We are going to look into that. Luxury, mass market, discount percentage. This is also kind of important. And why it's important will be seen in future slides. And then simple moving average, exponential moving average, and stock values. So we created all these extra features into a model. And for some reason, I don't know. Can I just pause for a moment? Okay. Okay. So after feature engineering, we have some visualizations. So here, yeah, analyzing number of items sold and revenue across 3 product subcategories. Standard stuff. I'll not get into quickly try to just give you an insight here. So there are two major categories, right? So one is luxury and there's mass market, and then we split the number of items sold. So on the y axis. So here you see gaming accessory and the blue one, that is camera accessory, are kind of sold in the mass market. And when you come to luxury, you have the green one. So that's home audio. So basically, it says that home audio is the category where luxury items are sold. So that's kind of an insight that we get from here. Next is the same kind of same graph, but we come into percentages. So you see the percentages for home audio. Again, you see luxury is sold more for home audio compared to camera accessories and gaming accessories. So basically, what we're trying to do is we are trying to analyze our revenue and a number of orders, that basically sales, with respect to two categories, that is luxury and mass market. So this slide, so this is like a big question, right? So anybody would like to know what are the top product verticals which has the highest number of orders in all the 3 product subcategories. So here you see home audio. So there is a home audio speaker in home audio, and then second one is a headset in gaming accessory, and then a gamepad in gaming accessory. So these are like the top 3 product verticals, and of course the top 10 are all shaded. So the higher the color intensity and the bigger the square, the more the magnitude of that particular product. Great. So after orders, we go to revenue. So this is revenue. I mean, revenue also, you see home audio speaker is bringing the highest revenue to the company, and then lens in camera accessories. So with this, you get an idea like which other features are important that go into your model and which bring out the most revenue. So that's like getting a hang of the features available that go into a model, right? So yeah, so now we analyze how revenue is based on discount percentage. So this is kind of important, but we'll just put here. So what happens when you give different discount percentages and how your revenue changes according to that. So you can see here, when you give a discount of 50 to 60%, your number of orders is the highest. So please note that this number of orders, this is not the revenue. So this is like the sales, that's not the revenue. So between 50 and 60%, you get the highest order. So this is an insight, and all this insight build up later at the end in the model. So yeah, here this shows the difference between GMV. GMV is basically gross merchandise value, which is a revenue, and then count is basically your number of orders. So here you see between 10 to 20%, we have the highest number of revenue. And for the number of orders, when you give, this is from the previous slide, right? So 50 to 60%, you had the highest number of sales. So this is kind of an insight. So it's all based on strategy that you want to do. If you're that comes in the next slide. So here, coming forward, we'll see. I mean, there are this basic concept of optimizing first on market share and then on profit, right? So market share, revenue, and then on profit. So if your objective is to optimize on market share, then you better give discounts and then you increase your orders. So that's how it is. But if your objective is to optimize on profit, then you need to give discount between 10 to 20%. So that's the idea. But we'll see in the next slides as well. So impact of discount on revenue. So luxury and mass market, again, you see mass market products basically have a higher discount percentage that is between 50 to 60%, and you see the median value right here. And for luxury, the median value comes between somewhere between 20 to 30. That is somewhere between 20 to 40. That is 30% discount for luxury, and 50% discount for mass market. Okay. This is another stuff. Simply you see between 10 to 20%. Your luxury items will find that around 35% of the products where a discount given between 10 to 20% are luxury products. So between 10 to 20%, if you give the discount, that's where luxury items are sold. That's what it says. This is evident from the previous slides as well. So this is what I was talking about, right? Strategy to optimize. So first we optimize on market share, revenue, and profit. So that's what it is. So if you want to optimize on market share, have a high discount value, and if you want to optimize on profit, then you can basically give a smaller discounts of 10 to 20%. So and then increase your revenue. And it all depends on the product as well, the type of underlying product that you're trying to sell. So customers also need to find value in that, and they should not feel that okay, if a product has high discount, it doesn't mean that the product. It should not mean that the value of the product is low. So such things need to be taken care. The same stuff, revenue and orders. Earlier we looked on discount percentage, but now we're looking on payment times quickly. So again, here on the left hand side, it's GMV, which is revenue, gross merchandise value, and then on the right hand side is the number of orders. What are the three product subcategories? Home audio, gaming accessory, and camera. Y-axis has all these three product subcategories. So you see, COD and prepaid has more or less the same effect on your revenue, but your number of sales is basically showing that people trust COD more than prepaid. So that's one thing that company can look into. So they can focus more on COD, but at the same time in future, they can also focus on prepaid by building trust. And trust can be built by having, as you saw that, right, having an application and customer support, etc. So that's another insight. Various media channels investment by week. Quickly put, this are the different media channels, the respective colors across the weeks. Weeks is on the x-axis from basically 28 to 26. So that's from June to July 2016, right? June 2015 to July 2016. All it says that sponsorships and online marketing and search engine are the most important channels that you need to look into. So these are again the features that go into your model. Effect of media investment on discount and revenues. This is another stuff that we need to take care. So so you see the graph which is on below, that's the second graph, which has promotions on ads on the left, on the y-axis, and week. So this is like your input, and the graph which is above is your output, which is you're interested in. You're interested in GMV, right? But you want to see how your promotion and ads affect GMV based on the weeks. So this is kind of an informative plot here. You see, total ad investment is kind of high between the weeks of somewhere around 39 to 45 weeks, and at the same time you also see a spike in your GMV. So it's kind of obvious. So when you increase your ad investment, you get a higher revenue. So that's how you can look into it. So this also goes into your model, these features, the promotions and the discounts. So your blue line is your ad investment, and these three lines, right, the red and the blue and the green, are your percentage of discounts, which are the two inputs that go here. So again, on week 39 to 45, the discounts percentage also increased for the three product subcategories, and as well as the ad investment. So for these weeks 38 to 45, you have a spike in your GMV. So that's what is mentioned here, why week 4 was here. So so this, somebody who is taking this offline and wants to read through can just read through this. Brief description of linear regression models built. So now we come basically to the models built, right? So we have built additive and multiplicative models, which we'll be just going through, and then comparing which model is the best suited for us here. So quickly, simple stuff. Additive linear model is basically impacts are also additive towards the dependent variable y. So that's what it is. Y is a dependent variable and all the other variables are your independent variables. Alpha is a constant and betas are your coefficients for that particular variable. Coefficients are basically the magnitude and the intensity that applies to that particular feature or variable. So multiplicative is the same stuff, but instead of straightaway additive, you take the log on both the sides, and basically the values change, the whole values of the data frame change. But essentially it's the same. When you see, it's in the end it's a linear model, right? So it's the same stuff. It is said that basically multiplicative model captures interaction effects and current effects much better than the linear additive model. So let's see whether this premise holds true going forward. So yeah, so these were like the coefficients that or the different features that go into the model. So advertising, pricing, discounts, and then quality, and then T for trend and seasonality. So all this is we have been discussing all this long. Quickly, because we are running short of time, just quickly run through. And this is kind of important. A model dashboard. It's like a snapshot of all the results that we obtained from a model. So the rows are camera accessories, gaming accessories, home audio, the three product subcategories, and the columns are basically your metrics of your model. So R2 is R square for additive model, ADD is additive model, null is multiplicative model. You compare which one is higher. So for a multiplicative model, in general, you have a higher R2 score. And you also see the mean squared error for a multiplicative model is also on the lesser side. So we choose the multiplicative model for all the three subcategories. And the features that go into the model, the top features. So these features is based on basically all your trial and error and basically using different models like RFE-CV and RFE, and also cross-validation. And based on that, we come up with a model. So basically, we have extensively used RFE-CV here, which is evident in our code. RFE-CV predicts the top features that should be going into the model and the number of features, right? At the same time, also giving a higher R2 score. But at the same time, as a data scientist and as a business analyst, we need to see the business impact of those models and what variables that need to go into the model. So it's like it's not a science, it's like an art. It should be a balance of both. So that's what we have done and we have chosen. So this shows our data frames for the three product subcategories. So in the first camera accessory, we chose 10 features for a high R2 score. In the second gaming accessory, we chose 5 features. And again, home audio, we chose 5 features based on the RFE-CV, based on what RFE-CV suggested us to use. So we'll just run through this. So you see the constant is basically higher compared to all the stuff. That's like without doing anything for any of the other features, you will still manage that amount of constant value in your linear model. So that's what it says. This is the same stuff, but plotted just to have a visualization. Constant has a higher value and all the other features. So based on these features and based on the coefficient values, so the plots are basically the coefficient values in which variable has a higher impact into the model is all seen here. Quickly again run through this with the plots above. This is how a best fit line looks. So for camera accessory, you have a constant of 14.9 plus some magnitude times your feature, magnitude times your feature, magnitude times your feature, right? So the magnitude comes from this plots, basically this data frames and your feature. So that's what it is. It's just a simple linear model. And yeah, this is what we are expecting. We want to use this best fit line for our future predictions for the three product subcategories. So yeah, this equation implies how much the revenue will grow with the unit growth in any of these independent KPIs with all other KPIs held constant. Am I recording this? Okay. I'm just going to pause for a moment and just check your screen sharing. Recording, yeah, recording is on. Great. So I thought I did not on the recording. Cool. So this now we come to the major recommendations. So as a company marketing head or a CEO or a CMO, I would be interested in looking into the different product verticals that are contributing to the revenue, right? And then different media investment channels that are contributing to the revenue. And finally, whether the product category is a mass market or a luxury. So based on this art that we want from the marketing side, from the CMO side, we need to choose these variables, which also lead to a higher R2 score, but at the same time also explain your model in a much better way. So these are the recommendations that I would like to give to the company ElecKart if they are taking, basically our company services as a consultant to them. So lens and camera battery contribute to the increase in the revenue. This is seen here. Lens has a magnitude of 1.01 and then camera battery. Coming to the media investment channels, affiliates contributes positively, and you can see this is interesting insight. Online marketing contributes negatively, so you need to cut down on your online marketing and allocate the same budget to affiliates or some other variables which increase your revenue. In general, mass market products are better contributors to increased revenue in comparison to luxury products. So this point is seen in all the three subcategories, which you will see going forward. So sorry, camera accessories done, gaming accessory, gamepad, gaming headset, gaming mouse, product verticals, increasing revenue, gaming accessory kit, reducing your revenue, affecting revenue adversely. Marketing channels, affiliates and TV, positive impact that you can see here. Affiliates. Yeah, so I have actually used this. So based on RFECV scores, this is what I have put here. So RFECV is again in the code. You can have a look at it. But RFECV says that affiliates and TV are known to bring positive impact on the revenue. There's something concept of ranking. The RFE is a ranking, right? So I have used that. Mass market products are better, and then you can see that discounts, higher percent discounts don't work for this category. So as a business analyst, I would try to recommend to stop giving the higher percent discount for gaming accessory. For home audio, the same stuff. Which product verticals? Home audio speaker and FM radio contribute positively. Marketing channels, sponsorship ads. Sponsorship is basically contributing positively, whereas your investment in ad stock is contributing negatively to the revenue. And then the same insight as before, mass market products are better contributors than your luxury products to the revenue. So with that, I think we are coming to the end of this PPT. Some other visualizations which are kind of not important for a CMO, but may be kind of interested to a technical lead or a technical head. So trends in NPS, NPS and stock exchange. This can again go with this weekly breakdown that we had seen earlier, right? So week 31 to 36 is where you have a high NPS score. And these are the weeks, if you see, where the discount was high. So that is what is kind of an insight that is put up here. And the company stock value, of course, as it is. So this is another insight. Holidays does not play an impact on the revenue and sales. So people don't, whenever they need a product, they just log in and they buy. So holidays does not have much impact here in Canada as such, as a geography. So yeah, this is kind of some technical plots that we have plotted. This is like a pair plots from the revenue to all the other variables. Here you see affiliates and online marketing have a higher steeper curve and of a kind of a best fit line or linear regression curve, whereas radio has not a steeper curve. So with this, you can just inside that affiliates and online marketing affect your revenue, which is also seen in our best fit line, right? So most of the three product categories had affiliates affecting GMV positively, and had online marketing affecting GMV negatively. So some model validation visualizations, standard stuff, whether a model is correct or no. So assumptions on linear regression, right? The error terms are normally distributed. So that's seen here in the first plot. And then independence of error terms, we don't see any specific pattern. So, and then your homozydicity. So constant of error terms. So there is again no pattern here. So all these assumptions are valid. So this is for camera accessory. And then the first column plots, right? The first 3 plots are basically on our train data. So train is basically actual train minus actual train bread. Y is dependent variable. So that's what is plotted. And then the next 2 plots, which are below, are basically on a test data. So this is testing your model, actual and predicted on test data. So the blue is your actual and the red is your predicted. So you can see more or less both the model is predicting well. And then your best fit line, linear regression curve. So the model is pretty doing good here in camera accessory. Same stuff on gaming accessory, normally distributed, independence of error terms, and then constants of error terms, and then your actual and predicted on test data for gaming accessory. The line on the green stuff, multiplicative model. So it mentions that is the multiplicative model. And then your best fit line. Same stuff for home audio, normally distributed error terms, independence of error terms, constant of error terms, actual and predicted on test data for home audio, more or less the same. You can see that the red and the blue line are all or in sync. So a model is doing pretty well here. And that's all. So we saw our models predicting well the top features affecting revenue. And we had a model this, right? So our recommendations and a best fit line. So this is kind of important stuff that we need to look into. And finally, that's all I have to say. Thank you very much. I'll just go to the end of the slide. And of course, if there is somebody else who's looking into this video and want to get in touch with me, these are my contact details: email ID, my LinkedIn profile, and my phone number. And that's all for me. So this is a part of the submission of Triple IT and Upgrad. I would like to take this opportunity to thank Triple IT and Upgrad for this learning experience. It was a great learning experience, 1 year almost. So today is 31st December 2021, and it's great. It was a good learning experience. Thank you very much. Have a good day. Take care. This is Achal Kagwad signing off. Bye bye.